Welcome to this lecture on magnetic leakage calculations. In electrical machines, it is impossible to confine all the flux through the useful path only. That means some part of the flux will be passing through the non-useful paths, and that flux is known as leakage flux. And leakage flux plays an important role in the performance of electrical machines. For example, in the case of AC machines, the leakage flux causes leakage reactance voltage, which has an important role in the performance of AC machines. Similarly, in the case of DC machines, since there is leakage flux, we have to provide additional field excitation to compensate the loss of flux. And in addition to that, due to the presence of a leakage flux, there will be reactance voltage produced, which um, affects the proper commutation in DC machines. So generally it is very much difficult, or it is almost impossible to estimate the leakage flux accurately through mathematical calculations. So usually the results obtained through calculations are checked against the experimental data. Now let's see which are the different types of leakage flux present in electrical rotating machines. The different types of armature leakage fluxes are slot leakage flux, tooth-top leakage flux, zigzag leakage flux, overhang leakage flux, harmonic or differential leakage flux, skew leakage flux, and peripheral leakage flux. First one, slot leakage flux. The fluxes that cross the slot from one tooth to the next and returning through iron. It is known as slot leakage flux. So this leakage flux passes through the slot and returns back through the iron. This is known as slot leakage flux. So they link the conductors below them. Next is tooth-top leakage flux. Here, as the name indicates, the flux flowing from the top of one tooth to the top of another tooth. That means this is one of the tooth and this is another tooth. So this leakage flux passes from this tooth to this tooth through the top portion of the tooth. So this is known as tooth-top leakage flux. And this leakage flux is considered only in machines having large air gap length like DC machines and synchronous machines. But in the case of induction machines, this air gap will be very small. So this kind of tooth-top leakage flux can be neglected in the case of induction machines. Next is zigzag leakage flux. And as the name indicates, the flux passing from one tooth to another in zigzag fashion across the air gap is known as zigzag leakage flux. And the magnitude of this flux depends on the length of air gap and the relative position of the tip of rotor and stator teeth. Next one is overhang leakage flux. Overhang in a rotating machine is nothing but a conductor which connects the two sides of a coil. In this figure you can see a particular coil which has 3 turns. Okay, so this is one coil side and this is the other coil side. So these 3 conductors connects the 2 sides of this coil. So this is known as the overhangs. And the flux which is produced by the overhang portion of the armature winding are called overhang leakage flux. So at this point, at this end, these are the overhangs, and At the other end, these are the overhangs. So on both sides, there will be overhang leakage flux. And overhang leakage flux depends on the arrangement of overhang and the nearby metal parts. For example, end covers. Next is harmonic or differential or belt leakage flux. The harmonic leakage flux is due to the dissimilar mmf distribution in the stator and rotor. So the difference in the harmonic contents of stator and rotor mmfs produces harmonic leakage fluxes. So in the case of squirrel cage induction motor, the rotor current is exactly balanced by stator current. So there will be no harmonic leakage flux. Next is skew leakage flux. As you know, in the case of rotor of induction motor, there will be a twist provided on the rotor surface. The twist will be provided in order to eliminate the harmonic torques and noise, and it is known as skewing. The skewing reduces the mutual flux and thus creates a difference between total flux and mutual flux. This difference is accounted as skew leakage flux. Next is peripheral leakage flux. The fluxes flowing circumferentially around the air gap without linking with any of the windings are called peripheral leakage flux. Usually, this leakage flux is negligible in most of the machines. Thank you.